¿Qué tal? ¿Cómo están? ¿Qué dicen acá? Yo soy Miguel Moctezuma. I'm gonna explain you something about the topic in fluid mechanics that is called boundary layer. And what I'm gonna do is I'm gonna make an explanation of the boundary layer equation and the solution of Blasius, the guy who was a German guy who made this solution and was a student of Prant. So what I'm gonna do is I write first my equations. This is bx multiplied by bx partial bx derived by x plus by multiply bx divided by y derived, and this equals nu partial second bx by y 2 times. And this equation is for a boundary layer that if we have a plate, and the plate will have a uniform velocity profile here, and the velocity would arrive here, and if near the wall the boundary condition is that both velocities are equal to 0. Bx and by are equal to 0, because the particles here are at rest. But near there the particles start to move because of the flow, and this one would move faster, this one a little bit slower, and it was almost in rest, and in some way it become a velocity profile over there. So we can put it like this maybe. Yeah, okay, so it would be like this, something like this. Okay, so the velocity would increase far away from the plate until the velocity u infinity. So we need to find a way to obtain bx and by, and we will obtain this with a similitude method. And the solution of Blasius is something called based in a method that is called similitude equations. And also we need to solve the continuity equation. So we have here the also partial bx with x plus partial by divided by derived by y equals 0. That's a continuity equation. So we need to solve that. And so what I'm gonna do, I will define my variables first, and the variables are here. So we have a variable that is a potential function that is equal to f eta, and then we need to define that eta and the function eta, and the function eta is equal to y multiplied by b infinity divided by nu x elevated to 1 half, 1 divided by 2. That is the function eta. And the other is the function f eta, and I will write here the function f of eta is equal to this. We have here the potential function that is already defined here, p dx y, and this will be divided by u infinity and this variable nu x divided by u infinity elevated to 1 squared. We see that these quantities are the inverse of this one, and we will know later on that this value nu infinity nu x divided by y is delta. That's delta is the thickness of this boundary layer. In this way, this delta is growing over the layer, and we will see that this delta. So we can see that eta, in fact, is this j divided by delta. In some way, it's a quotient of the variable y divided by the thickness of the boundary layer. We have here the x axis and here the y. I should have started with that, but well, that's a little mistake right now. Okay, so I will delay here. These are our equations. Well, they're already in the video, so you can only return there and go to there. And what I'm gonna do is first we will obtain, well, I will write my equations. I will write again eta equal to y by b infinity nu x elevated to 1 half. And here we have p equal u infinity multiplied by the other nu x divided by u infinity, and that multiplied by f eta. So what we're going to do, first we will obtain the first our velocities. We have to need to obtain here. Bx is from potential functions, but the way that the potential function is defined. Bx equal partial phi divided by x. We know that with this we will satisfy the continuity equation. And if we do this, we see this here, the function. So we have u infinity and f it's divided by y. So we have this function that doesn't depend on y, so we only write it, nu infinity. And we have here f eta, f prima, that is the first derivative of eta, and then we have the eta and the x. That's right. Do you agree? So if you know that the eta, we can divide it by here. So will be equal to u infinity. We'll only write again these terms, and we have f eta, and eta this is only because it's divided by y. We are deriving by y, so it's only u infinity nu x. It's only the term, this term that rests on the derivative. The y is a constant, so we only put the constant. And as you see, this one cancels with this, and we can put bx equal e infinity multiplied by f theta. This one is simple to obtain, it's easier. We will obtain now by. This will be a little bit more difficult. I will erase this now. Okay, now the next time, okay, the next term will be with y. I always put some music when I'm doing these derivatives. You can do that slower in your house to study if you want. So we have now by is equal to minus partial phi divided by derived by partial x. So we have again our function here. So we only put here minus u infinity, and we will do first we put constant this, and we leave it like that, u infinity by 1/2, and we derive f eta, and derive partial f again x. So partial eta again x, and so we have here this term that is y by nu infinity divided by x, and this would be nu x at 3.5. But we can put here 1/2, and we only put one x here. So this is the derivative. You can do it with calm in your house. This is the first one, and the second one. This is what because this one is minus half. We would the minus with minus would cancel, and we have here 2. So we have this sinus plus. And then the second one we would have the second term would be minus equal u infinity and then f eta, and we make this derivative, and this one is easier. It's only here again. We will put here u infinity divided by x because we are minus half, so it will be minus elevated to minus 1/2, and here we have divided by 2. Okay, these are the two terms. I will put the result here in the top and simplified. So we will see what is the result of that. This one I already erased it. So the result of that is kind of simple. You can make the algebra. I will not go into the details simply because this is u infinity. You can see that this would be in the top. So we would have here u infinity like this, and also in this term, because this u infinity would go here, so we would have u infinity. Okay, so we have this, and after doing all the algebra, I would not bother you with all that. You can review in your house, and you can do that. Is 1/2 multiplied by nu b infinity divided by x to the 1/2, and it would be eta by f prima de eta. You can hear this here term here is because of that, and the other term would be minus f eta. Okay, so I will not jump too much into the details. I will put it again in the next video, but just to explain a little bit. I will stop here and let's see how it stays here, and I continue with the second part in the next video.